For this small data set, we're going to calculate the least squares regression equation. So that's y hat is equal to b naught plus b1x. And we need to find our estimate for the intercept and our estimate for the slope. And so we can do this with this small data set by hand. The first thing that we need to do is know the calculations for each. So b1, our slope is equal to r times s of y over sx. So these are the respective sample standard deviations for the y's and the x's. And b naught is equal to y bar minus b1 times x bar. So these are the averages of the y's and the averages of the x's. So we can calculate x bar and y bar by simply just taking the averages of the x's and then the averages of the y's. So this can be done by simply adding them up and dividing by the total of them. So x bar is equal to 2. We find that y bar is equal to 4.5. And we can also calculate the sample standard deviation. So S of x is equal to, if we wanted to calculate this by hand, it would be the square root of the summation of each observation minus its mean squared divided by n minus 1. I'm not going to do that here, but you can do it if you'd like. So Sx, I've already done it, is equal to 0.816. And my standard deviation of y, which can be calculated in the same fashion as up here, is equal to 1.291. And lastly, the thing that we need is we need the correlation coefficient. So we've already calculated this in a previous example, but we could calculate it if we wanted to by hand by doing 1 over n minus 1 times the summation of each observation of x minus the mean of x divided by the standard deviation of x times its respective paired values, so yi minus y bar, the average of the y's, divided by the standard deviation of the y's. So we could calculate it by hand here. I've already done this, so we've calculated the correlation coefficient to be 0.949. And so now we can use these values to calculate our slope. So b1 is equal to r times sy over sx. So this is equal to r, which is 0.949, times s of y, which is 1.291, divided by the standard deviation of the x's, which is 0.816. And this is altogether equal to 1.5, approximately. All right, so that's going to be our slope value. And our intercept is then just equal to our average for the y's, so 4.5 minus our calculation for the slope, 1.5, times the mean of the x's. So this is times 2. We'll get that from over here and over here. And we find that 1.5 times 2 is equal to 3. So 4.5 minus 3 is equal to 1.5 as well. So it turns out that our intercept and our slope are actually the same thing. That is just kind of a fluke thing that doesn't typically happen, but it did in this example. So y hat is equal to 1.5. That's my intercept. So b naught plus my slope of 1.5 times x. So this is the least squares regression equation.